4 or something like that. Okay, so we're here, it says day 7. It says multiplying. It's like at the bottom of this page, right here. Okay, so this secretly has a 1 here. What is this index right here? What's this number? 2, very good. So this is equal to x to the 1/2 power. That's it. So this is going back a couple days. Do you have any questions on that? Okay, remember that index is always the denominator of the fraction. Oh, one thing I also forgot to say about that last test. I am offering retakes, but you have to retake it by next Friday, just like when your grade sheets do. Okay, so if you feel like you didn't do so hot on that test and you want an opportunity to retake it, I'm being very generous. I'm allowing you to retake it, but you're still using that note card that you already turned in. Okay, but you can go ahead and have a whole weekend and a whole week to study and get yourself to take that test if you would like to. That's an option, okay, because Miss Hurd did that as well. All right, so let's take a look at this next one. There's an index of 2, so I would have x to the 4 over what? 2. And then I would have y to the what over 2? 3. Very good. Do you have questions on that step? This is from before, so hopefully you kind of remember. All right, well, the only thing that I can reduce here is this guy in yellow. What is 4 divided by 2? 2, and I'm going to be done. Do you have any questions? Okay, this next set of questions, I'm not going to move, so people are still writing. It just says to extract any roots that you can. What does that really mean? I'm sure you guys have been reading that directions and not really understanding what it really means. When you extract roots, it's like you're taking out a perfect square. You're taking out a perfect cube. That's what it means to extract. Extract means remove, right? When you're like a surgeon, you extract something. Okay, so extracting means you're removing all the perfect squares or the perfect cubes to get the final answer. So here, we don't have any numbers. That's okay. So this one's, I put this one on here for a reason because we tend to struggle with these types of ones. The index is secretly 2, so let's talk about this. There's a couple ways to do this problem. How many times does 2 go into 9, or what's 9 divided by 2? How many e's can I pull out? 4. Here's why. Think about that. I'm going to use my fingers right now. 2, 4, 6, 8, 10. 10's too high. I only have 9. Okay, I have to use 4 groups of 2, which is 8. Okay, so if I took out 4 groups of 2, which is 8, how many e's are left inside? 1. Now let's talk about this guy. I have 13 f's. I need to figure out how many 2's I can pull out. Let's think about that. 2, 4, 6, 8, 10, 12, 14. I went too high. So I can only take out 6. Because 6 times, hold on. Yeah, 6 times 2 is 12, right? So I have f to the 6. So how many is left inside for my f's? If I took out 12 from 13, 1, and we're done. I also showed you guys, if you weren't here, which a lot of you were not, if you do like 13 divided by 2, which is this guy, you would get 6.5. That 6 is what you're using here if you weren't here. So it's another way to do it in your calculator. Same thing with the e's. 9 divided by 2 is 4.5. That 4 is where I'm getting this 4 from. Yes? I was just showing that on Wednesday, if you do 13 divided by 2, you'll figure out how many groups you can pull out, which is why I pulled out 6. That number in front tells you how many you pull out. Okay? All right, let's try it again. What is the square root of 64? You should know that one. 8. So that's coming outside for sure. Now let's talk about this. What is 8 divided by, I'm going to write this out for those that weren't here, 8 divided by the index of 2? How many? 4. 8 divided by 2 is 4. So then I would have x to the 4th power, and I'm done. Or you can think, how many times does 2 go into 8? Think about that. 2, 4, 6, 8. That's 4 times. Okay? And then nothing's left. If you don't get a decimal in your calculator, then nothing stays inside. Question. So that's review from Wednesday if you were not here, which I think 3 or 4 of you may have not been. Okay? All right, go ahead and flip. This next one is going to be the same thing, guys, except for you're just doing one more step ahead of it. You're just going to multiply now, or divide. So it says multiplying radicals. When you do that, there's something called the product rule. And that means that all you're going to do is you're going to multiply them together inside the same radical. Okay, so if I have the square root of a times the square root of b, that really just means the square root of ab. Okay, and I'll show you an example of that in a second. Okay, like for example, if I had, you don't have to write this down, the square root of 2 times the square root of 3, I would have the square root of 6, because 2 times 3 is 6. But it's going to stay inside. That's really the only thing that we just learned right there. Okay, now, remember when you multiply, your index must be the same. Remember that index is that little guy like inside the little house, that little itty bitty number. And then what happens when you multiply exponents? So if I had something like x squared times x third, how many x's would I have? 5. You added, right? So that's what I was asking. You add your exponents when you multiply. Okay? Questions on just that part? And you're actually going to find this to be pretty easy if you were good at what we did on Wednesday. Wednesday was one of those topics, and I actually emailed you all separately if you weren't here, and I said, this was an important topic if you're going into STEM, so please watch the video. Okay, I really mean that. If you have time over the weekend, you really need to make sure you know how to do radicals because it's like one of the biggest topics in STEM. So if you missed Wednesday, you missed an important day, unfortunately. Just make sure you watch the video. I made sure the sound was there, everything was there for you to watch. Okay, here. All we're going to do is we're going to multiply the inside. So we're going to get out your calculator. I'm going to put it side by side here. And I'm going to do 27 times 5. 27 times 5. And it gets me 135. So it equals the square root of 135. So it's still under that little house, under the radical, but you do multiply them. Now, we have to think so that we can simplify what is the perfect square that goes into 135. Now, a lot of you can go back to your notes and you can make your list. However, I do want to show you that there is a way to make your own list. If you were on the test and you didn't make a note card or you wanted to make it yourself, you can. So I'm going to write a list out for you. We have, just go in order, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. You could just be going in your calculator right now and just doing 6 times 6 is 36. 7 times 7 is 49. You're just making your list of perfect squares. 8 times 8 is 64. 9 times 9 is 81. And then 100. And we can stop there. You really don't have to go any further. But you can make this list without having to look at a note card. You just go 1 times 1, 2 times 2, blah, 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 blah. So we have to ask ourselves, what perfect square that we just listed goes into 135? Well, I'm going to show you for those that weren't here how you do this. Okay, I do 135. Let's start dividing by, I don't know, let's go up as far as we can, 81, and let's see if it works. Nope, 135 divided by 64. Let's see if that works. Nope, 135 divided by 49. Nope, I'm going to keep going. 135 divided by 36. Nope, still not working. 135 divided by 25. Oop, that was not right. 135 divided by 25. You guys could probably be faster than me because mine's not that fast. We're getting close though. 135 divided by 16. What's up? 15? Oh, we're getting there, yeah. So then we have 135 divided by, you said 15? 9, which gets you 15. Good, okay. So 9 and 15 works. I probably should have done 9, but that's the perfect square that goes in there then. Okay, so I have, let me break it down. It's been really laggy, so I apologize. I don't know why. Just give me a second. What is going on? There we go. Okay, so this breaks down into the square root of 9 times the square root of 15. That came from your calculator. Okay, any questions on that? Well, what is the square root of 9? 3, and this guy stays in. So my final answer is 3 square root 15. Now, it seemed like a long process, but really all you're doing is plugging some numbers in your calculator to see which one works. And once you get used to it, it's so much faster than the other method. It really is. Because once you get the highest perfect square, you're done in one step. Okay? Do you have any questions?
Same thing as
Yep, so the only new thing that we're learning today is we're multiplying the first step. That's all. And then the next page it's dividing. Okay, so now same thing, but now let's take a look. I'm going to multiply the outsides. So what is negative 2 times 3? Negative 6. And then I have, in purple, 18 times 10, which is what? 180. Are we okay there? Now we're back to Wednesday. So if you were not here, this is a perfect opportunity for you to learn what we did Wednesday, because this is literally it. This is the same step. Now, there's a lot of perfect squares that go into 180. There are. But you have to find the highest one. Okay, so I'm going to keep going. I have 180 divided by, let's say, 64. Let's see if that works. Nope. 180 divided by 49. Nope. 180 divided by, bless you, 36. And there we go. It's 5. So we're going to use 36 and we're going to use 5 because that was the highest perfect square that goes into 180. So this breaks down into the square root of 36 and the square root of 5. And we're almost done already. Because what is the square root of 36? 6. This comes out, this stays in. Now, normally your answer would be 6 square root 5, but remember you have to multiply 6, right off to the side, 6 times negative 6, which gets me what? Negative 36. So negative 36 square root 5 is my final answer. Again, because you have, whatever you pull out, you pulled out a perfect square of 36, which is 6. You multiply it to what's on the outside, and you get negative 36. Okay, so it's just a lot of, like, logic and moving things around. The perfect square that goes into it. You're extracting that perfect square out. You're removing it from that situation. Questions? Okay. Where are we at here? All right, I am going to do this cube root 1. Now, we don't have a list of perfect cubes, but we, again, can make one. So I'm going to go on the bottom now, because we're not going to do that one. We're not going to do E. I'm going to make a list of perfect cubes. So I'm going to make this little list. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Yep. I'm just writing it on the bottom of this page so that we have a list. 4 times 4 times 4 is 64. Or you could even be doing this in your calculator. 5 caret 3 is 125. Okay, I don't even know 6 cubed, so I'm going to put that in my calculator. 6, not 66. 6 cubed, yep, is 216. And I think that's okay. I really don't think I'm going to be giving you anything really that much higher than 216. So we can just stop there. But you're going to use these now to help me with my cube roots. So here we go. On the outsides, what is 2 times 5? 10. Very good. I don't know why that just happened, so hold on. I've been having a lot of issues with my computer lately. I get 10. Then I have cube root of something. What is negative 24 times 9? I put that one in your calculator probably. Negative 216. Well, this one should make you happy because it's literally on your list, right? 216 is on your list of numbers of perfect cubes. Just because there's a negative there doesn't mean anything. Okay, the negative, if you actually put this in your calculator, I'll show you how. Press math. See that option 4 right there? It's the cube root. So option 4. And then I would put in negative 216, and you'll see that it's going to give me back a negative 6. So the perfect cube is negative 6. That comes out. Now remember, you have to multiply. What's negative 6 times 10? Good, and we're done. There's nothing else that's left in. Like when you took the square root, you got 6. There's nothing left. There's nothing for you to do there. Okay? Are we feeling okay? Especially because we did this on Wednesday mostly, for those that were here that day. Give you a second to make sure we got it written down. Got my calculator out. All right, this next one. Now we're just working with some exponents here. I have 8 times 6, which gets me what in purple? 48. It's still under the radical. A lot of people, what I've noticed even last period when they were doing their homework, they left the radical out. They left the square root out. But you have to keep that inside. It's still inside. X to the 5th times x to the 7th. We add exponents. So what's 7 plus 5? 12. Okay, and then also here in green, y times y to the 9th, you add them, and how many total y's do I have then? 10, because that's secretly a 1 there, right? So I have y to the 10. Do you have questions on that? Now, the last period, someone said 6 and 8 to get 48, and you're right. That does go in there, but neither of them are perfect squares, right? There's no perfect square of 6. There's no perfect square of 8. So let's find one on our list, go back to our list, and figure out which one goes into 48. So I'm going to do 48. Let's try 16. I feel like 36 is too high to even try to go in there. 25 is a 5, so I'm not going to do that. So 48 divided by 16. And look, that works. Square root 16 and square root 3 is what I'm going to break that one down into. So I have the square root of 16 times the square root of 3. Are we okay on that one? What is the perfect square? What's the square root of 16? 4. That comes out. This stays in. The 3, there is no perfect square of 3, so I'm going to keep that inside. And let me show you how I set mine up, like just so like you get that process down. The 4 is on the outside, the radical's on the 3. If you notice, I leave myself a space because I probably know that there's going to be some letters that come outside. Okay, some people don't do that, and then they kind of jumble up the letters with their numbers inside the radical. So here I go. What is 12 divided by 2, the index of 2? 6, so I have x to the 6th power. Are we okay there? Especially for those that weren't here, please ask if you have questions. What is 10 divided by 2? 5, so I have y to the 5, and that's it. There's nothing left. If you don't get a decimal, that's all you got left. Okay? We're going to skip the next one and go to F. And the division one's pretty straightforward on the back. Okay. Okay, this one, not that bad. Let's just take it just like normal. It looks like a distributing problem because there's a number on the outside. So let's do that. I'm going to multiply these. Well, 8 times 2 gets me 16. What is x times x? X squared. They're still both under the radical. They are. They're still under there. Minus square root 2x times square root 32. Let's go ahead and put that in our calculator. 32 times 2 gets me 64. So I have square root. Yep. I know. I said we're going to skip that one. Yeah. Then we have an x there. Now let's just break them down. What is the square root of 16? 4. What is the square root of x squared? Anyone know? X, yeah. You have a pair, so it's just 4x. That's what came out. Minus, bring down the minus sign. What is the square root of 64? 8. Then that square root of x stays in, and we're done. Okay? You can't take 2, which is my index, out of 1. I only have 1x. There's no way I can take 2 from 1. That's not possible. So that's why that guy still stays inside. Okay, and then flip when you're ready so I know I can move on. I don't want to rush you, though. We're not going to do all of it today, actually. We're only going to do the dividing part. We'll do the rationalizing on Tuesday. Okay. Dividing, same thing. Just like we did with multiplication, basically what it's going to all just now be under the radical. So for example, if I had like the square root of 8 divided by the square root of 2, I would have the square root of 4. Like you would just divide them is really all I'm saying. Okay? So same type of process now. Your index has to be the same. You can't divide. Yep. Mm-hmm. So then your index must be the same. So what I mean by that is you can't have like the square root of 8 divided by the cube root of 2. Those are different. You can't divide. It wouldn't be the square root of 4 anymore. That's not possible. So you would have to keep it that way. There's nothing to do there. Okay, so that's what I mean by that. They have to be the same. Now, what do you do when you divide? Do you add the exponents or do you subtract them? Subtract. So it's the opposite of what we did on the first page. Subtract. Okay. Now let's give it a go. This one's not that bad. Let's take a look. All we're doing is dividing. What is 48 divided by 16? 3. Can I break down 3 any further? No, it's done. That one was an easy one. So it's literally like just division, but you're keeping it under the radical now. It's the only change. Let's do it again. Now, some of them are outside, some of them are inside. You have to be careful. So here I would have 12 divided by 2, which is 6. And then I would have in yellow here 60 divided by 5, which is 12. Can I break down 12 further? Yeah. What perfect square goes into 12? 6 does, but you can't take the square root of 6. 4, which is 2, so were kind of right here. So the square root of 4 and the square root of 3. Because 4 times 3 gets me 12, and 4 is a perfect square. If you guys do this and not one of them breaks down, you need to rethink about your numbers. Okay? But you could do it the other way. It just would take you longer to do it. But the square root of 4 is 2, and this guy stays in. I like to underline noting that stays inside. Well, is my answer 2 square root 3, or what would I have to do? I have to multiply. So 2 times 6 gets me 12, and then square root 3 stays in. And I'm done. Now, some people, and this was very common from last period too, a lot of people told me, don't write this down, but a lot of people said, okay, what about 6 and 2? That's great. But do you see how I can't literally take the square root, so I had to keep going. This would be the square root of 3 and the square root of 2. Then I need to be like, okay, these multiply, and I get square root of 3 times the square root of 4, and look, you just went back to what you just did. So you could do it that way, it's just going to take you a lot longer to do it. Does that make sense? Yeah. No, I was just showing you that it would take you longer to do it that route, that's all. Okay? All right. I am going to stop there because I feel like that's enough for your brain on a Friday, and then Tuesday we'll pick it up. So I'm going to have you cross some things out on your homework because obviously we didn't get to everything today because I want you to get your homework done before a 3-day weekend. Looks like, let me just come on up here. Yep. We're going to do that on Tuesday, but I'm going to give you a different worksheet with it on there. Yeah, so you can just cross it out. Okay, so number 4. I'm just going to start it. You have to finish it, okay? So it looks complicated, but it's not that bad once you see what you have to do. It's the same thing, but now you have more than just 2. I feel like you could have figured it out without me, but I wanted to make sure that no one was confused by it. Okay, so this is what you have for number 4. Same thing, but now you have 3 of them. 2 times 4 is 8. 8 times 8 is what? 64. So the cube root of 64. Now we do it again with the a's. I have 2 a's plus 3 a's makes 5 a's. Plus 5 more a's, how many do I have? 10. And now in blue I have 1b, 2b makes 3, plus 6 gets me 9. So now I started it for you. You have to finish. It's not completely done. You have to simplify now. So that first step, this is like now from Wednesday, right? This is like same exact problem now. Okay, so you have to keep going. You know the cube root of 64 is blank, and you keep going. The key is up to check your answers.